Take a look at the 5 symbols below. What do these symbols mean? Where have you seen them before? What different situations? The 5 symbols below are different inequality symbols. We have the first 2 are less than and less than or equal to. The small part of the symbol is facing towards the left. The next 2 symbols are greater than or equal to. The small part of the symbol is facing now towards the right. It's in the opposite direction. We also then have the symbol of not equal to, which is an equal to symbol with a slash through it. This is the opposite of equal to. It's also important to note when you have equal to in the symbol in the inequality, you have that line underneath, like these 2 symbols. That line underneath the symbol, again, means or equal to. So these 5 symbols are all examples of inequalities, but they do mean different things, and you have to keep in mind which one is which. An inequality is a statement that 2 quantities are not equal. The quantities are compared by using one of the following symbols or signs. So here each row is representing one of those 5 symbols we just were shown, and here we're now comparing A and B. So the first row we have A is less than B, we have A is greater than B, A is less than or equal to B, A is greater than or equal to B, and A is not equal to B. Now that's just variables A and B. When are you ever going to use this? Where will we see inequalities in real life? One example is looking at certain parts of a breakfast cereal. So your parents and grandparents want you to start eating a healthy breakfast. The table below shows the nutritional requirements for a healthy breakfast cereal with milk. We have fat has to be less than 28 grams, protein has to be more than 5 grams, fiber has to be at least 3 grams, and sugar has to be at most 5 grams. So if we're given this table or this chart, suppose your favorite cereal has 2 grams of fat, 7 grams of protein, and 3 grams of fiber and 4 grams of sugar. Is that considered a healthy cereal based on this chart? Well, you would need to know how to interpret these different inequalities. These statements here mean different things. If you have 2 grams of fat, is 2 grams less than 28 grams? If you have 7 grams of protein, is 7 more than 5 grams? If you have 3 grams of fibers, is 3 grams at least 3 grams? And if you have 4 grams of sugar, is 4 at most 5 grams? You have to know how to translate and look at the inequalities to answer those questions. If you can say yes, then you have a healthy cereal, and you can prove to your parents and grandparents that you've been eating healthy this whole time. What about a cereal with only 3 grams of fiber? Is that considered healthy? Well, again, if we have at least 3 grams, you would have to interpret, is 3 at least 3 grams? Now, knowing inequalities, you should be able to say, yes, it is going to be at least, because at least includes equal to 3. But again, it's really the importance of translating at least into an inequality to compare, which we'll study next. One more example, though, is a cereal with 5 grams of sugar considered healthy. Again, if you're looking at most 5 grams, how can you interpret that? You should be able to say, yes, it's right on the border, but it is included in the at most 5 grams. If it was 1 more over with 6, you wouldn't be considered healthy anymore. Just like with the fiber, if you had only 2, you wouldn't be considered healthy. So you have to really look at what you're interpreting. Does that inequality include the equal to? Is it going to include the number itself, or is it just less than or greater than? So these are important things to consider when translating from these words we've heard all the time to these now inequality symbols to compare two values. So here's a table we can use to help with that translation, right? It's not just going to be greater than or less than or greater than or equal to or less than or equal to. You're going to see other words like is more than, must exceed. We also have is greater than sometimes, but let's look at some samples of how they're used in real life and then how we can translate that to an inequality. So first with is more than, our sample is Trenton is more than 10 miles away. So you can have Trenton is 12 miles away, Trenton is 20 miles away, 30 miles away, 50 miles away. You can't have 10 miles away, though. That doesn't make sense for the scenario. So you have to think that Trenton is greater than 10 miles away. And if we use the symbol a lowercase d for think of distance, we can translate that for is more than to d is greater than 10. So is more than, we're going to relate to the equivalent inequality of greater than. Now, if you have is greater than, such as A is greater than B, you can go straight to the translation with the inequality symbol because we have the variables A and B, and greater than has a symbol. So A is greater than B looks like that. Now, notice it's important when I'm translating, I'm reading the statement from left to right, and then I'm writing it from left to right as well. Very similar to equations and expressions. I'm just interpreting it exactly as I read it. Now here we have must exceed. So that's not one of our straightforward symbols, so we have to interpret which one that would mean. So for example, the speed must exceed 25 miles per hour. So I could have 27 miles per hour, 30 miles per hour, 50 miles per hour, 60 miles per hour. I can't have 25 miles per hour. That does not fit the conditions of the scenario. So that's going to be equivalent to the speed is greater than 25 miles per hour. So if we use a lowercase s for speed and the symbol for greater than, we can then have s is greater than 25. So these are actually all three different examples using the greater than symbol, interpreting that inequality, but we started out with three different types of words. We had more than, you could have your straightforward greater than, but we also could have must exceed, and it all translates to that one inequality. Let's look at some more. Here's three different words that aren't going to all mean greater than. So here we have cannot exceed, is at most, and is at least. So let's think of some sample sentences in real life where we might have heard them and how we can translate them. So first, let's look at cannot exceed. Our example is time cannot exceed 60 minutes. So you can have 59 minutes, 50 minutes, 45 minutes, 1 minute. Could it be 60 minutes? Think about that. Yeah, 60 minutes would fit the qualification of not exceeding 60. It's just equal to 60. But you have to have numbers that are then less than or equal to the 60 minutes. So if we use a lowercase t for time, you would have t is less than or equal to 60 as the inequality. So now we have is at most. I'm going to tell you the last two here, is at most and is at least, come up a lot in inequalities. So it's really important to know which inequality symbol we're going to use when comparing with these words. So for is at most, let's use the example, at most, 7 students were late for class. So you want to think 7 students could be late for class, all 7 of them. But maybe 6 or 5 or 4, 3 or 2 or 1. You wouldn't want 8 though, that wouldn't meet the qualification. So that you don't want over 7, you want 7 or fewer students. So you could have the 7, you could be equal to the 7, but less than 7 also. So if we use a lowercase s for students, you can have s is less than or equal to 7 for that inequality. And then we have is at least. So Bob is at least 14 years old is our example. So you want to think Bob could be 14, so we're going to include or equal to 14, but he could also be 15 or 17 or 20 or 30 or 40. So he can be numbers, his age is greater than or equal to 14. So if we use a capital B for Bob's age as our variable, we could have B is greater than or equal to 14 as our inequality. So now, think of these given inequalities. How would these be read? It's almost like going backwards. So the first would be 3 plus 3 is greater than 4. So the difference is we have our symbol kind of in the middle of our two comparing expressions. So we always have 3 plus 3 on the left, but we're going to have different symbols. So the first one again is 3 plus 3 is greater than 4. for this symbol. We have 3 plus 3 is greater than or equal to 4. We have 3 plus 3 is greater than or equal to 5. These are all true inequalities. We have 3 plus 3 is less than 7. 3 plus 3 is less than or equal to 7. We have 3 plus 3 is less than or equal to 6. And we have 3 plus 3 is not equal to 5. So all of these inequalities are true. This is how we're reading the inequalities. And this is kind of the most important part, is taking that symbol and interpreting it in words, what it means for that inequality sentence. So let's translate a statement into an inequality. So here we're starting with words and then we're translating to the statement. So we have first over here, we have x is less than 40. So the variable x comes right down. Is less than, we have our symbol here, and then we have the number 40. So again, we're reading from left to right and just bringing each part down with variables, symbols, and numbers instead of in words. Here's another example. 30 is greater than or equal to y. So the 30 comes down. Greater than or equal to uses this symbol, and then we have the variable y. So it doesn't matter if the variable is on the left or the right. It's just interpreting it straight down from the words to the inequalities. So let's try these. We have 5 examples here written in words, and we want to translate them to the inequality. So for number 1, we have 14 is greater than a. So we have 14. Here's the greater than symbol and the variable a. We have number 2, b is less than or equal to 8. So we have b and 8, and in between is the less than or equal to symbol. We have 6 is less than the product of f and 20. So we have 6 is less than 20f. We have 8 is not equal to a number n. We have the sum of t and 9 is greater than or equal to 6. So we can include operations as well, as you see with the product and the sum, as long as we're interpreting the inequality part into the symbol. Here are 5 more. So again, we're translating from the words into the symbols. So we have 7 more than w is less than or equal to 10. We have 19 decreased by p is greater than or equal to 2. We have fewer than 12 items. So here's an example where the symbol is not straightforward. We have to interpret fewer than. So fewer than is another way of saying less than. So some amount of number items, and we're using the variable n for those items, has to be less than 12. So fewer than is interpreted as less than. Number 9 is no more than 50 students. So the amount of students S we're using is no more than is another way of saying less than or equal to. So we're using that symbol compared to 50. So we have S is less than or equal to 50 for 9. And then 10, we have at least 275 people attended the play. So we're using the variable p for people. Now, at least, we're going to interpret as greater than or equal to. So for 10, we have p is greater than or equal to 275. Now, here's an example where we now have a problem where we can see a store's employees earn at least $8.50 per hour. So we can define a variable and write an inequality for the amount the employees may earn in 1 hour. This will help us with problems in the future if we need to set up the inequality to solve. So here, we're going to pick E to represent an employee's wages. Then we have at least, we know to interpret it as greater than or equal to. And then the $8.50 per hour is $8.50, which is, we're going to just consider it 8.5, so E is greater than or equal to 8.5 is the inequality that can represent that situation and help you solve inequality problems in the future. So when translating, the most important part though is this middle step where how are you comparing your two expressions? Look for the words used and see which inequality symbol it matches up to.